Hi everyone, we are from group 2. My teammates are Huoda, Anbo, Yiming, Xinxin, and myself, Yaping. In this video, we are going to present a case study on Golden Village Smart Cinema. I will first give an introduction to the business situation, the tasks that our team are onto, followed by Xinxin. She will explain the details of exploratory data analysis and key mean clustering. Yiming will continue with the predictory model of movie popularity. Anbo and Huoda will explain the recommendation system. For this project, we have created this hypothetical business situation of Golden Village. Golden Village, as most of us know, is the most popular cinema operator in Singapore since 1992. It operates 15 cinemas across Singapore. The business has suffered a lot in the past 2 years due to COVID. Our team is trying to use a data science approach to help Golden Village to best capture post-COVID growth. We have 3 tasks in mind. The first task is to decide whether to acquire the movie title to screen for the cinema. The second one is to effectively launch targeted ads and promotion to moviegoer by providing a precise recommendation. The last task is to propose a user-centric closed-loop data system for Golden Village. So for this project, we used a movie dataset downloaded from Kaggle. The movie dataset is originally from IMDb. It contains 45,000 movies released before 2020. We have performed data cleaning and data preparation. We removed useless and incomplete variables. We also only kept English language movies released after 2005. Some of the data is in the form of JSON, for example, the movie crew, directors, and movie runner. We have extracted useful data for our analysis. For certain columns with more attributes, we have split the column and stacked them. I'll stop here and Xinxin will take over on EDA.
Thanks, Yaping. To better understand our dataset, we conduct EDA first. Next slide, please. Since our project considers popularity as an important goal, so we mainly focus on finding factors that will affect popularity. From the left graph, we can see movies released in June and December have relatively higher mean popularity. That may be because people have more free time due to public holidays and so on. The right graph, we can see some kinds of movies have relative higher popularity mean than others. Top 3 genres are adventure, action, and fantasy, which are easier to make audience feel excited, while documentary, foreign, which have smaller audience and a bit rough to express the core of the film, may lead to lower popularity. Next slide, please. Now, let us zoom in the relationship between popularity and production country. The left graph is about movie number and country. Most movies are produced in United States, followed by United Kingdom, and the US produced most comedy and drama films. The red graph shows the popularity among different combinations of genres and countries. Red color represents higher score, while blue represents lower score. Higher popularity scores are UK's family and fantasy movies, New Zealand's animation, and India's science fiction. Next slide, please. Next, we performed a production company segmentation to help conduct following predictive model. Since our origin dataset is based on movie, we should transform it to company level. We extract average budget, average revenue, number of genres, average runtime, movie numbers, and popularity as independent variables. But after correlation detection, we found average budget, average revenue are highly correlated. Movie numbers and the number of genres are correlated. So we only kept average budget, average runtime, movie numbers, and popularity. Also, as the bottom picture showed, 5 is the most suitable number with highest CCC. Left is a chart showing difference of clusters, and there is a company example of each. There is no obvious difference in runtime. Mainly differences are on budget, productivity, and popularity. Next, Yiming will help introduce predictive model.
Okay, thanks, Xinxin. In order to explore the important factors and provide evidence for Golden Village about which movie to screen in the cinemas, we use the multilinear regression and also the random forest method to predict the popularity of movies. Before build the model, we firstly conduct some pre-work to ensure accuracy. As you can see, the scaled variables such as budget, revenue, and popularity are all transformed by log, which creates a more even distribution. Secondly, we created dummy variables and used one-hot encoding for category variables. We selected top 3 genres, which are comedy, drama, and documentary based on the movie quantity. For company, we directly use the cluster results as new identifiers. In addition, since 70% of the movies are produced by American companies, we added variable US movie to interpret as country influence. After data processing, we conduct correlation analysis for the collinearity check. As you can see, the coefficient of revenue and budget is nearly 0.7, and we only kept budget to build our model. Next, please. Here is the result of multilinear prediction. The R-square is nearly 50%, and all the independent variables are statistically significant. As you can see, cluster 2, 3, 4 companies have the top 3 largest positive coefficients. Based on our cluster result, we can note that movies produced by big companies with more budget and quantity of movies are more likely to become popular. And movies with higher vote score and produced by American companies also tend to have higher popularity. Besides, we can see that the coefficients of top 3 movie genres are all negative, especially for documentary. It indicates that the quality of movies with these types may vary, since there is large number of movies with the same genres, and cinemas need to consider other factors and select seriously. Next, please. Next is the random forest method. The variables are the same as the linear regression. We firstly made the chart to select suitable depths of each tree and avoid overfitting problem. As you can see, the chart here shows the variation of mean squared error of training and testing dataset with the increase of max depths of trees. It shows that there is an obvious trend to become overfitting when the tree depth exceeds 10. So we selected 10 as the max tree depth. And the R-square for training, testing, and validation are higher than 60%, which means it performs better than the multilinear regression model. Next, please. Here is a part of one tree in the random forest and the importance of variables. From the result, we can see that budget, vote average, runtime, and genre documentaries are more important factors to influence the popularity. And after analyzing the tree split, we found that the movies with higher budget and vote score are more likely to have higher popularity. And on the contrary, the documentary movies and movies with longer runtime tend to have lower popularity score. Next, I will hand over to Amber to introduce our recommend system.
Thank you, Yiming. For our recommendation system, we will have 2 different kinds of models. One is the content-based filtering system, and one is the collaborative filtering system. And I will be introducing the content-based model first. Next, please. As the name suggests, the content-based recommendation system is built based on the content of the service provided. In our case, it's the movie contents. And the purpose of this system is trying to make a guess what movies a user may like based on his browsing history. And the system works by using some selected features or attributes assigned to the movies and matching them to the features and attributes in our dataset. So next, please. So that will lead to our first step, which is to identify which features can be used to find out the similar movies. For example, one important feature that can be used to indicate the similarity between two movies is the genre. Let's say a user has watched a movie A, and the corresponding genre of A will then be taken into account when the system trying to generate a list of movies for the user. And this list of features are what we used in our system. One is the cast, which is basically the actors in the films, and then the crew is a group of people who participated in the film production, providing practical or technical direction. The most well-known crew members will be like directors, production, camera and lighting, and so on. And then the production company, production country, and also finally the genre. Next, please. So these are the methods we used in when we building our recommendation system. First is the count vectorizer, which is used to transform a given text into a vector on the basis of the frequency of each word that occurred in the entire text. And once we have the text transformed into the bag of words format, we use the content metrics to generate word vector embedding. And of course, more detailed system building steps will be elaborated in our report. Next, please. In the screen, it shows one of our example, one of our results generated in the above example. When typing in a movie, let's say The Dark Knight Rises, one of the Batman series released in 2012. The top two movies are also Batman series, which is interesting. The following ones are either crime or the superhero themed movies. So let's move on to the next slide. Why do we choose the content-based filtering? First, the system needs no data from the other users to start making recommendations. Once a user watched a certain movie, a content-based filtering system can begin making relevant recommendations. This makes it ideal for the newcomers who don't have an enormous pool of users to sample. And the content-based recommendations are highly relevant to the user because the content-based filtering is able to recognize the specific user's preferences and tastes. The quality of early recommendations is generally better than collaborative system as well. For the collaborative system, it requires the additional and correlation of millions of data points before becoming optimized. And of course, the content-based filtering has a disadvantage. This system lack of novelty and diversity. For a recommendation system, we will always expect it to be able to come up with more diverse and unexpected results. And next, I will pass to Hoda to introduce our collaborative filtering system.
For collaborative filtering, on the other hand, doesn't need anything else except users' historical preference on a set of movies. Next, please. Because it is based on historical data, the core assumption here is that the users who have agreed in the past tend to also agree in the future. In terms of user preference in our case, is explicit rating. It is a rate given by user to a movie on a sliding scale from 1 to 5. For example, like a user gives 4 stars for Titanic, This is the most direct feedback from users to show how much they like an item. For example, as shown in the matrix, user 2 has given movie 2 at 2 stars. When the entry is a question mark, it represents that the user has not rated the movie before. And what's the outcome of the recommender system? Next slide. The goal is to fill all the empty entry by the predicted recommended scores. Now let's focus on what are some standard methods. Next, please. The first one is the nearest neighbors. In fact, it is the model used in our assignment too. Nearest neighbors algorithms are user-based similarities. When users are similar, they tend to like same movies. However, there are quite few limitations of this method. It doesn't handle sparsity well when no one in a neighborhood rates a movie. That is what you are trying to predict for a target user, which is true in our data set. There are approximately 99% of the entries are zeros. Also, it is not computational efficient as the growth of the number of users and movies. Since sparsity is the biggest challenge for nearest neighborhood method, here comes a more advanced method that next slide, please. That decompose the original sparse matrix to low dimensional matrix where latent factors and features and less sparsity. And the advanced method is related to matrix factorization. Let us see an interesting application of matrix factorization. The grayscale of 400 images of faces are the raw input, and 10 of the faces are as shown. Applying matrix factorization on the raw data, we can obtain 10 typical faces that can be used to rebuild all the 400 original faces. Each original faces can be represented by a linear combination of the 10 typical faces. And in our project, we apply the similar idea to reduce the size of rating matrix by finding the typical users and the typical movies. Next slide. And which algorithm to use? We use root mean square deviation, the RMSE, to choose model-based algorithms, and the RMSE of each algorithm is as shown in the table. Therefore, we decide to use SVD, is singular value decomposition, since it has the smallest error. Next slide. And what's the result? We obtain a recommendation score matrix. Comparing with the raw ratings, it is obvious that we fill all the zero entries with a predicted recommendation score. After ranking the recommendation score for each user in ascending orders, we can obtain the top N movies that we would like to recommend to them. In our system, we recommend the top 10 movies. Next slide. Okay, there is a user 547 who rated the greatest number of movies, that is approximately 2,400 movies in the data set. Here is the list of recommended movies to user 547. And there are also many users who only rated 20 movies before, for example, like user 1. And here is also the list of movies recommended to user 1. Next slide, please. Let us try to interpret the recommendation to user 457 to see if we can make a guess of the latent factors. Latent factors are related to user preference but hard to be manifested. And what are some features of movies user 547 has rated before? From the left bar graph, we know that he preferred drama the most. And from the table on the right, we can see 60% of the recommended movies are drama. Therefore, we can conclude the Giovanni's movie is related to the latent factors. Next slide, please. And also from the left bar graph, we know that 457 prefer class 2, which is the big movie production companies, and 50% of the movies recommended are produced by leading producers. Therefore, production company is also related to latent factors. Next slide. And another evaluation metric of our recommender system is personalization score. For example, in a very simple recommender system built on the popularity score of movie, all users will be recommended very similar movies, while in our system, we design a metric to compute similarities of the prediction between each pair of users, and we find that the personalization score is 70%. Next slide. To conclude, the advantage of collaborative filtering method is that there is no requirement for movie descriptions, while the disadvantage is that it suffers from cold start problem. For example, we cannot recommend movies to new users or when the users have not rated any movies previously. Okay, I will hand over to Yaping. Yaping, are you muted? Sorry.
Unmute yourself. Sorry.
Okay, sorry. Our group has proposed this closed loop data ecosystem to Golden Village. I will just highlight 3 key steps here. Start from data collection. Golden Village can collect data from internal sources, and it can also purchase data from external sources such as IMDb or social media companies. Of course, it can generate its own interaction data. From those data, it is able to have analyzed a 360-degree view of customers and understand the movie industry much more in depth. That's the analysis part. It can segment movie companies, predict movie popularities, and also make recommendations to its users by being very precise, recommending a movie that the user will watch. Of course, it will generate more revenue by luring more customers to go to the cinema. So the last part is data feedback. Measurement could include, for example, user interaction, user feedback, or it can even conduct customer survey to measure its success of this data-driven system. Of course, the ultimate measure would be the business revenue. The leadership can, based on the review and feedback, we can upgrade the data system or its analytics model. So with all the hard work and analysis, finally, we come to summarize all our findings into this one-page recommendation to Golden Village. So the burning question, what movies should Golden Village choose? From our analysis, we would recommend Golden Village focus on movies from producers with high to medium budget. It should introduce more US movies and less documentary movies. On the recommendation system, for content-based recommendation, it can ask its users to fill up registration questionnaire so that the preference information can be collected. For collaborative filtering, Golden Village can incentivize existing user to sign up and provide review scores as much as possible. It can be shown in this photo. That's what existing members are providing reviews. It should also incentivize new users to sign up, and when they sign up, you will force them to provide a favorite movie when they first sign up. This would help them to avoid the cold start problem. And of course, Golden Village should build the user-centric closed data loop to sustain its data-driven journey. So that's all our presentation. Thank you.